Hey, fourth graders, it's time to do a little math. We're on page 727 in your math workbooks, and today's lesson is going to be about finding area. And remember, in our vocabulary, we had a definition for area. Area equals length times height. So length times the height. And when you start into this unit, the first thing that they do is they show you how to find the area of squares and rectangles. So, in order to find the area, what we're talking about in a rectangle is all of that surface area of that rectangle. And the example they give you in the book is 12 feet and 9 feet. And all you got to do to find the area is multiply the length times the height. So 12 times 9. 9 times 2 is 18. 9 times 1 is 9, plus the 1 you carried. It's 108. Now, in area, we're talking about how many cubic units, how many square units fit into that surface area. So in your answer, it's 108, and in this case it's feet, and I put a little 2 up there indicating that it's square feet. You can either write square feet like SQ abbreviation and feet, or just put feet and put the exponent 2, and that means the same thing. It's feet squared. Now, if it's a square, finding the area of a square is the same thing. The example they give you in the book, you have a square, and they're telling you that that square is 8 yards by 8 yards. The numbers are the same because in a square, all the sides are the same. So in this problem, it would be 8 times 8, and that equals 64, and that would be yards squared. Now, you all should be pretty good at multiplication, because finding area of any object requires multiplication. And if you're not firm on your multiplication tables, then you need to practice those, because I'm telling you, you just can't accomplish anything in math if you don't know the multiplication tables all the way through 12. Let's do one of these word problems just to give you a little insight. Word problems, I don't know why the words screw people up, but they do. It's all about numbers and the last line. What are the numbers? What is it asking you to solve? Number 5 on page 727. Bryson is lying down sod in his yard to grow a new lawn. Each piece of sod is 1 foot by 1 foot square. And sod, if you don't know what sod means, sod is grass and dirt all put together, and you can buy this in a 1 foot by 1 foot square. How many pieces of sod is Bryson going to need to cover his yard if his yard measures 30 feet by 14? So now we've got a yard, and it measures 30 feet by 14 feet. So we're going to multiply, because we need to find how many square feet are in his yard. So it's going to be 30 times 14, which is 420 feet squared. 420. So if each chunk of sod is 1 foot by 1 foot, he's going to need 420 of those, because that's how many 1 foot by 1 foot squares are in his yard, 30 feet by 14. Now, when figuring area, where this gets a little complicated in this chapter is when you have an unusual shape. And there are no unusual shapes. Nope, in lesson 13.2 there are no unusual shapes. So those problems we took out of the homework are a good representation of what the area of a square or a rectangle are. Now, in lesson 13.3, which starts on 729, now they're going to challenge you a little bit. If you look on page 729, you see Jan there is visiting a botanical garden with her family, and she shows the garden. Now, let's just draw that garden, because when you have a shape like that, and you want to find out what the area of that odd shape is, there's a couple ways you can do it. Let's put in the dimensions. They're telling you that this is 8, and I'm looking at metric meters here. It's 8 meters. This dimension is 3 meters. Each one of these dimensions is 4 meters. This dimension is 4 meters. We're missing one dimension here, and it's this one here. And it says overall, it's 7 meters. Now that's a lot of numbers, and your brain is probably going, what does all this mean? It's really, really simple, because regardless of what the shape is, it can be broken into separate shapes. This shape has a rectangle and a square. Now, the rectangle can be defined by drawing a line across right there. And what you end up with is a square down here and a rectangle up here. And you can do each one of those separately. And then you can say what the total area is of that shape. Now, you have to be smart enough to sort out the numbers. We know that it's 8 meters in its length, and it's 3 meters. It tells you right here that this is 3 meters. So this is going to be 8 times 3. And down here, the square, well, we know it's 4 meters here and 4 meters here. If it's 4 meters plus 4 meters equals the 8 meters, so you know that all the sides of this are 4 meters. So this is going to be 4 times 4, and that's going to equal 16, and that's going to equal 24. Now, you just add those two numbers together. You got 24, 16, your answer is 40 square meters. So meters with a little 2 exponent indicating that the answer is in square units. So you see how easy that was? Just because it's an odd shape doesn't mean you can't make regular shapes out of it, squares or rectangles, and then just figure the area of those separately. Add them together, and it gives you your answer. Now let's see if we can find a shape that's really confusing here. Well, there's any number of them that are really confusing. I want to pick problem number 3 on page 731 because that looks like it could be the toughest one for you to figure out. And here you've got a shape that looks like this. And then it comes down here, and across here, and down here. Now let's fill in the measurements. Now these are in miles. So we're looking at this dimension here is 10 miles. This little rising dimension here is 2 miles. From here to here is 8 miles. Its height is 7 miles here, and it's 9 miles here. And that makes sense. Why does it make sense? Well, if it's 7 miles to here, and it's 2 miles there, 7 and 2 equals 9. See how when you look at it, you can kind of sort out the numbers. Now, finally, it tells you the overall length is 18 miles. And we can verify that because from here to here is 10 miles, and from here to there is 8 miles. Altogether, they equal 18 miles. So, this should not be all that difficult. Now, there's a couple of ways you can do this. You can either break it into 2 rectangles like that, going across, or you can come down and separate it here and give you your 2 shapes. It doesn't matter. Either way, you're going to get the same answer. So let's do it this way first. We know that from here to here is 9, so our height is 9, and from here to here is 10, so that is 10 times 9, and that's going to equal 90 miles squared. From here to here is 8 miles, so the length is 8, and the height is 7. That's 56 miles. So we have 90 and 56. We add those together. 90, 56, it's 146 miles squared. See how easy that is? Now, just for giggles, we know the answer is 146. Let's do it and break it up the other way. Because you can. As long as you can break the shape into regular shapes. Remember, our answer was 146 miles squared. If we take this and break it that way, this rectangle here, we know it's 2 inches high, or sorry, 2 miles high, and we know it's 10 miles. So that would be 10 times 2, and that equals 20 square miles. Now, the big rectangle we have here, we know that its height is defined right here. 7 miles, so the height is 7 miles, and the length is 18. 18 times 7. 7 times 8 is 56. 7 times 1 is 7, plus the 5 is 12. So now we got 126 miles squared. So we end up with 20 and 126. So we got 126 and 20. Add them together, 146 miles squared. You see, we got the same answer and we solved it 2 different ways. So looking at any shape, just break it into squares or rectangles. Then just use your standard formula of length times height. Remember that your dimensions, your answer is in square units. I'm going to do number 4 too, because I just got a feeling that that one's going to screw you up. Only because this problem offers a different challenge. Our dimensions are 16, and we're talking feet in this model. Its overall heights are 8 feet, and it's the same on both sides. It's 8 feet high. From here to here is 8 feet, and it's saying that these two are 4 feet. So let's see, 4 plus 8 is 12, plus 4 is 16. So we know everything is correct. Now, if it's, oh, there's one dimension missing, and it's the height of this, and it's 4 feet. So this is 4 feet high for these sides right here. Now, what I see is a rectangle in 2 squares. You're going to make your line right across. You're going to have a rectangle here. We know that it's 4 feet high here, so you subtract that from the 8. So the height of this rectangle is 4 feet. Because you have 4 feet here and 4 feet here, it equals the 8. And its length is 16. So that's going to be 16 times 4. Each one of these squares, remember all sides are equal in a square, so it would be 4 times 4. So we have 4 times 4 plus the second square, 4 times 4 plus 16 times 4. Now, that looks like an awful lot, but it's not. You can, and I put the parentheses there because you got to solve each one of them and then add them all together. 4 times 4 is 16, plus 4 times 4 is 16, plus 16 times 4 is 64. 4 times 6 is 24. 4 times 1 is 4, plus the 2, 64. Do you see how fast I did that in my head? Now, when you can do multiplication in your head that fast, you'll be really good at this. So anyhow, we got 3 numbers. We got 1 shape, 2 shapes, 3 shapes. 3 numbers. 16 and 16 is 32. Plus 64. So our answer is 96 feet squared. See, the toughest problem in the whole book. And you figured it out. Well, that'll take you all the way through lesson. Oh, there's a good one. Ooh. I think we'll do one more problem. Only because when you look at a shape, you know, your mind can go goofy. And before you even try to solve it, you think to yourself, oh man, I can't figure this one out. Here's a really funny shape. Where's it go? Yeah, this one. And again, when you look at this, there's really only three shapes. And you can cut it up any way you want. You just got to be able to figure out what the dimensions of the part that you've cut it into are. And sometimes you have to add or subtract and figure out what the right dimension is. But let's put the dimensions in. This is 1 foot up here, across. 1 foot. Overall height here is 7 feet. This little area in here is 5 feet. It rises here 1 foot. Across here is 3 feet. And it's telling you that this is 3 feet. Now, right away, I see if I draw a line here, I've got a square. That is 3 feet by 3 feet. So that's one of our boxes. Now we still got this big L thing here to take care of. Now, we know that the overall height of this is 3 inches, and that this rise is 1 inch. So that means this height here, the height of this section, is going to be the 3 inches minus the 1 inch that represents that height. So this is going to be 2 inches. 2 plus 1 equals 3. So it's 2 inches high. And the 5 tells us what its length is. So this is going to be 5 times 2. You see, we're breaking it down into the parts. Now, the only thing we got left is this big skinny rectangle here that's 1 foot by 7 foot. So 1 times 7 plus 5 times 2 plus 3 times 3. And again, if you put parentheses around it, that means you got to solve the multiplications before you add them together. So 1 times 7 is 7, plus 5 times 2 is 10, plus 3 times 3 is 9. And that equals 26. 17 and 9, 26. And that's feet squared. This is fun stuff. I'll bet you guys really get into it. So that'll take you all the way through lessons number 3.1, 13.1 and 13.2. And go ahead and take a look at 13.3, or I mean 13.2 and 13.3. Look at the homework there. I don't see anything in that homework now that should stump you at all. That's our 4th grade math lesson today, kids. Keep up the good work. Take care of yourselves. Stay safe. Stay out of trouble. And do something kind for somebody today. See you tomorrow.